This is a video on the Criss-cross method for writing chemical formulae. So this method can be used to determine formulae for ionic compounds. And what's typical is that in an exam, they'll give you either a valency table, if they're nice enough, or what's usually the case is a periodic table. So you'll be given a periodic table and you have to work out from there how many ions, let's say, an element has, and if the ion has a positive or negative charge. And so remember that valency is basically the ability of an atom, or let's say a group of atoms, to form chemical bonds, okay, with other atoms or groups of atoms. Okay, in other words, you can think of it as like the bonding ability of an atom or a group of atoms. Okay, and just some terminology, some jargon. So an atom, an example of an atom, let's say, an example of an ion. So let's say sodium, Na. Okay, it's got a nucleus. Sodium has got 11, an atomic number of 11. So therefore it's got 11 electrons and 11 protons as well. So those two X's there, electrons in the first shell. 1, 2, 3, 4, 5, 6, 7, 8. 8 are allowed in the second shell, and one more in the outer shell. Okay, it's outer shell. Okay, outer shell electrons, so this one here, that's called a valence electron. Okay, it's the outer shell electron, in other words. So sodium is a metal, and metals, they tend to give away electrons. They like to give away electrons because the goal of any atom is to be stable. What does that mean? Stable in the sense that it's got, I should say full shells. Okay, full shells. It means that, so sodium in this case, if it gives away that extra electron, let's say tagging along in the third shell, it'll have a full first shell and a full second shell. So it's happy, right? So metals, they like to give away electrons. If you take electrons, so atoms are neutral. So sodium is neutral, let's say, sodium atom here. If you take an electron away, it becomes positive overall. Okay, so Na, okay, has an equal number of electrons and protons, right? If you take one electron away, it will now become positively charged overall. So we give it the symbol, okay, superscript +1, or sometimes just plus. Okay, that means it's lost an electron. It sounds a bit counterintuitive, but it makes sense if you think about it. It's now positive, okay? It's positive due to the loss of one electron, okay? Just write it as plus, Na to the plus. Right, that's sodium right there. What about, let's say, chlorine? So chlorine is a non-metal, okay? It's got an atomic number of 17. Okay, so it's got 17 electrons. So these 2 electrons, 1, 2, 3, 4, 5, 6, 7, 8. So it's got 10 here so far. So 10, 11, 12, 13, 14, 15, 16, 17. Now, with chlorine, you'll notice there's the outer shell is missing 1 electron in order to be stable. So what do non-metals like to do? Well, non-metals like to gain electrons. Okay, they like to gain electrons. So sodium and chlorine would go nicely together. And when they come together, they form what's called sodium chloride, or aka table salt. Okay, this is an example of an ionic compound. Ionic because it's made of ions, and compound because it's made of 2 different elements. Okay, so for chlorine, okay, a chlorine atom has, just like the sodium case, it's got an equal number of protons and electrons. If it gains, so +1, another electron, it's now negative overall. So Cl, and we put a minus at the top, 1. Negative because it's now negatively charged, and 1, it's gained 1 electron. Okay, we just write Cl to the minus. Okay, so sodium, let's say in this case, here, okay, this diagram is getting a bit messy, so I'll use a highlighter to emphasize my point. If the sodium gives away that electron here to chlorine, you will get an ionic compound. Okay, so Na plus, okay, so a sodium ion, sorry, Na plus Cl, you will get sodium chloride, NaCl. Okay, Na plus, I should write Cl minus. Okay, so the plus and the minus, they cancel to give you a neutral compound. What's important to note is that compounds are neutral, whether it's ionic or covalent, it has to be neutral. Okay, if you touch, let's say, table salt, you don't get electrocuted, because it's neutral, unless you do something to it, like zap it with electricity. Okay, it's neutral. It's made of ions, but when they come together, when the ions come together, you get what's called an ionic compound. Okay, so ionic compounds contain a metal, which is sodium, and a non-metal, bonded due to an exchange of electrons. Okay, so there's been an electron exchange between sodium and chlorine. Covalent compounds, however, they contain two non-metals. So let's say oxygen, two oxygen atoms bonded. That's a covalent compound. Okay, two non-metals, and they're bonded due to the sharing of electrons. So that here is a chemical bond. Okay, that's the oxygen atoms sharing electrons. Okay, they're both happy. So in the next video, I'll talk about how to actually name ionic compounds and covalent compounds.